Hi folks, welcome back to Physics with Captain Rod. The purpose of this video is just to go through an example of how to handle a typical RC type of circuit with a DC voltage source. So what we're looking at here, we've got this 20 volt potential hooked to this circuit that has a 50 microfarad capacitor and a 20 microfarad capacitor, a 5 ohm resistor here, 10 ohm resistor here with a switch in the middle. We're going to try to find the charge on each capacitor if the switch is closed for a long time. So we're imagining this switch has been closed. The battery will have charged up these capacitors to the following polarities. So we're going to have a couple of unknown charges. I'm going to call them Q1 and Q2. Now, an important thing to recognize is that if I picture a branch here, like this spot right here, there's going to be a current there as long as the charge Q1 here is changing. But eventually Q1 is going to hit its maximum value. And once it hits its maximum value, the current's going to go to zero. So this problem only has one current. And that current will follow, would be through this branch. Right? Same reason, we're not going to have a current over here because once this thing is totally charged, the current in this branch will go to zero. So the green represents a region where we are going to have a current. I'm going to go ahead and draw that current, I. I drew it in its direction based on the polarity of the battery because remember, the battery will always, assuming positive charge carriers, always create a current such that the charge carriers are going from higher to lower potential. As far as finding I, what we'll do is we'll go ahead and write a loop equation. Now I'm going to go ahead and do that. And again, the loop is going to be this loop right here. So I'm going to start here, go around clockwise to write that equation. And what we're going to have is plus 20 volts is the first potential we hit as we move through this circuit. We come down here, we're going to drop in potential by an amount IR. I'm going to put minus I times 5 ohms. Go ahead and write it like that. When we get to this point right here, we're going to drop in potential by I times 10 ohms. And then we're back to where we started, so this equals 0. It's a reasonably easy equation to solve here for the current. I'm going to go ahead and do that, and what we get out of that, let's see. We have, 1.33 amps. Right? Now, ultimately what we're trying to find are these charges. Well, from the definition of capacitance, capacitance is charge over voltage, right? So this can be rearranged for charge, no problem. The charge on a capacitor is equal to capacitance times voltage. But the important thing to realize is the 20 volts is not applied across the capacitor. So before we start actually calculating anything, I'm going to go back and color code the potentials like I like to do. So this is all one potential because it's all conducting material up to that point. Then we're going to have a drop in potential. I'm going to make the next one green. This is going to be another potential. Then we're going to have a drop across here, and this black is all one constant potential. So an important thing to realize is that the potential across this capacitor is the same as the potential difference here across the resistor, red to green, red to green. And we can calculate the potential across this resistor easy enough from Ohm's law. So we know that V equals I, which is 1.33 amps, times R, 5 ohms. That will give us the potential difference across this capacitor. So I'm going to go ahead and do that now. And I get 6.67 volts. So that's the potential difference from red to green. The potential difference here from green to black, I can calculate by taking the current I, 1.33 amps, and multiplying by the resistance, 10 ohms. And I get 13.3 volts. Now we can calculate charges. So the charge, let's see, Q1 equals, right now, charge is capacitance times voltage. It's important to know the voltage though. The voltage is the voltage drop from red to green. And I look across here, red to green. That was this term right here. So this is going to be a capacitance of 50 microfarads times the voltage across that capacitor, which is 6.67 volts. And I'm just going to leave the micro with the unit and take 50 times 6.67, 300, basically 333 microcoulombs. Remember that a farad is a coulomb per volt, and then times volts, we get coulombs out of that product. All right. Charge 2, the potential difference, or I'm sorry, the charge on the second capacitor, we can get by taking the capacitance, 20 microfarads, and we're going to multiply that by the potential across this capacitor, which is green to black, which is the same as this resistor, green to black, which was this value, 13.3 volts. And when we do that product, I get 266 microcoulombs. And I think I'm going to just leave this video off right here. That's all I really wanted to do with this video, is demonstrate how to work a short RC circuit problem here. Actually, I am going to do one more piece. Let's imagine that the switch is now opened. If the switch is now opened, that current's going to go to 0. This capacitor is going to find a new charge on it now. And the reason it's going to find a new charge is with the switch open, if there is no current across here, then this is all one voltage. There'd be no voltage drop across that resistor. And same thing up here. If there's no current, this voltage is constant right across that resistor up to that point. So now, this is with switch closed from above. With switch open, the charge Q1 is going to equal 50 microfarads times the voltage red to green. And I look over here, red to green is 20 volts. And that's going to be 100 microcoulombs. And charge 2 we can calculate by taking the capacitance, 20 microfarads, and multiplying by the voltage across that capacitor, which is red to green. And I look over here, red to green is 20 volts. And what we get out of that now is 400 microcoulombs. Let's see, looking at that, whoops, I think I got to go back here. Getting late in the day, a little tired. 50 times 20 is 1,000 microcoulombs. Most of you probably had already caught that ahead of me there, but let me go back and change that. So, 1,000 microcoulombs on Q1 or on capacitor 1, and 400 microcoulombs on capacitor 2. Hope this video helps. Have a great day.